up, guys? What's up, guys? Welcome back. Let me grab my phone. Ugh. Yeah, stream got cut yesterday. Oh, not yesterday, 2 days ago. Because that was the music I was playing. I gotta play copyright-free music, so I don't know. We're gonna try. We're gonna try some of this music here. I don't know. Hopefully, this is fine, but we'll see. I just got back from class, so it's probably gonna be a pretty short stream, but thought I'd turn it on, do some LeetCode problems or something. Been working a lot on some personal projects and stuff, but just gonna kind of jump into this. So let's take a look at whatever the problem of the day is. Minimum number of increments to form target array. So you're given an integer array target. You have an integer array initial of the same size as target. Okay. With all the elements initially zeros. In one operation, you can choose any subarray from initial and increment each value by 1. Return the minimum number of operations to form a target array from initial. The test case is also generated so that the answer fits in a 32-bit integer. So we're given a target array. You're given an integer target. You have an integer array initial of the same size as target. I'm a little confused with the problem, I'm not gonna lie. Trying to get a better explanation. Increments on subarrays to form a target array. Give me a better explanation. Let's see. And a target starting from an array of all zeros the same length. Turning it int. You can increment every element in a chosen array by 1 per operation. You can visualize the height of each bar. Okay, so the reason why it's 3 is we can go 1, we can go 2, and we can go 3. Here we can go 1, 2, 3. 1, 2, 2, 3. I'm a little bit confused because I feel like we could. I think we need to keep track of the largest number, but you can increment every element of a chosen subarray. We start from 0. We can visualize the height of each bar, level by level. Every time the height increases, you need a new set of increments to reach that new level. This is confusing. If I can solve it, this isn't hard. I'm trying to fully think about like what exactly we have to do here. That's the issue. Like, you only increment when the next number is higher than the previous one. Each time target I. To be honest, I'm still confused what we have to do. many new layers do I need to build to reach this shape? Let's take the array. We start with 0, 0. Number is like a height of a bar. Okay, yeah. Now every time the bar goes up from one to the next, we need to start a new layer of increments there. From 3 to 2, no new layer. From 2 to 1. How many layers we need? Is that what it is? Why is this 4? Why would we need 4 layers here? Don't we only have 3? I still don't get it, dude. Step 1, step 2, total 4 layers. Sub-array of zeros. You're given an array target. Yes, your job. You can pick any sub-array, a continuous section, and add 1 to all the numbers in that section. Ah, okay. That's where I'm missing it. Okay. How many times do you need to turn this all integers into zeros to target? Right, we take a simple array. 2, 2, 2. You can pick the entire array each time. Okay. That makes sense. Example 2. 1, 2, 1. Start at 0, pick the middle element 1. Increment the whole array once. Now we have 1, 1, 1, but we need 1, 2, 1. Step 2, pick only the middle element and add 1. Done in 2 operations. Okay. A continuous section, add. Let's play the music. Oh, whoops.
Enter the Spedience Gym Monster, an all-in-one home gym solution that aims.
Array of zeros. Okay. So it's a continuous array. Let's think about it, right? So we're given a target here. Let's make this music here. 0, 0, 0, 1, 1, 1, 1, 2, 2, 1, 1, 3, 3, 2, 1. Right, so let's kind of plan it a little bit. Give an input here, right? So to be able to do this, right, we have to go 1, 1, 1, 1, 1, right? Let's see, what are our constraints here? Okay. Right, and then we'd have to go 1, 2, 2, 2, 1, 1, 2, 3, 2, 1, boom. So it has to be a continuous block that we can only increment, right? So what sort of algorithm can we think about now? I was thinking dynamic programming. So I was thinking. Maybe some sort of DP array. So use a stack. How can we do this using a stack? I'm trying to think. We add one. Add one, add one, add one, add one. Maybe Metonic stack is where we use the index, right? I think from memory. How to... Trying to think here. Stood stack, stack, stood stack. We're gonna have integers stack, right? Try to think how we want to go about this. We add each value. We use a monotonic stack to add each value, and we use the monotonic stack to make sure that what we're looking at is all continuous, right? So I don't think how we want to go about doing this. You can't just do a range-based for loop. That wouldn't work, right? Let's think about this. Like, how is this for? So we have 1. We make everything 1. We make this one 2. We make this one 2. And we make this one 3. Right, so that's why. So... have to have probably some sort of while loop, I would think. But I don't know. Maybe like... First we have to create the array, right? So let's create a vector. Let's make this in the private section. Right. Make a vector of integers. We can call this initial. I can't remember how to do it, but I think this is size, and then so we go stack.size, and let's call this values. We go like values.size. Oh, that doesn't work either. And then the size, and then everything being initialized with 0. I think that's the syntax. Got the word zeros. Okay, yeah, that's right. Okay. Maybe we'd have to put this up here. I think that's probably a better place to put this. Right, so this is our initial array. Initial vector. Right. Now, how do we want to go about this? Well, we'd probably have to go, well, while... trying to think about it logically, right? How can we do this? How can we keep track of the that they're together? Yeah, I'm thinking you could easily do this brute force, right? But with a n squared loop. But if we were to do this using a stack, let's think about it, right? We have our stack here. We look at this value here, right? We see that it's a 0, right? Trying to think here. We'd initially look at this and this would be a 0, right? We're looking at this and it's a 0. Right, these could be zeros, right? So we have to think about that at first. These could be zeros, so we'd have to compare our current I that we're looking at to what this is, right? Maybe we can have like maybe some sort of like current val, right, that we're looking at, right? You know, so we're looking at the first level, right? So the current value we're looking at is 1. This is the value that we want to find, right? If it is this, then no, that wouldn't work, right? Because how do we keep track of the index? I'm gonna look at a hint, dude. I'm not sure. Given a range of values at a target, an optimal strategy is to increment the entire range by the minimum value. The minimum in a range could be obtained with the range minimum query or segment trees algorithm. It's to increment the entire range by the minimum values. Will that be like a first minimum? Increment the entire range by the minimum value. So we loop through the entire thing, grab the range, right? We see here the minimum value is 1, right? And we can make everything 1. But then what would we do after that? Like, what's the point of doing that? That's not really like... I feel like that wouldn't really work as an algorithm. This is a tough problem. I've never done something like this, so I'm not really 100% sure. Yeah, I'm not sure. Maybe I'm gonna ask for a hint, dude, because I'm not sure. 1526. All of increments on subarrays. So right now I'm kind of thinking about a heap solution. I mean, sorry, a stack solution. Can you give... Oh, shit. Can you give me a hint? We want this. Using the operation that increment all numbers continuous by subarray by 1, we want to continue how many such operations. Key observation without a stack. When target rises, say 2 to 5. 3 new operations to lift the section higher. When it goes down, you don't need any new ones. Previous increments are already covered. Each target as a height, like bars in a histogram. Okay. So maybe we're thinking too much about like actually think about these problems. We don't actually want to simulate the problem. We want to think about it like mathematically, I think. So instead of having an initial, let's do a base case here. Like, if target, we just want to return 0, right? Otherwise, do we want to loop through target? I don't know. Would a for loop work in this case? Probably not. Like, I feel like it'd have to be a while. Or in I is equal to 0, I is less than target.size, I plus plus, right? And check, well, if target I is greater than our current height, let's create like a current height here or something. We'll do like int current height, right? We start at 0, right? If target I is greater than current height, right? Because current height, can they be negative? No, it has to be greater than 1. Yeah, so we're guaranteed to be greater than 1, so it can be 0, right? If target I is greater than current height, we then increase by 1. Height plus or equal to 1. And then we set current height to be peak target I. No, that wouldn't work. Trying to think here. Sylvia, what's up? Hi. Nice to meet you. Thanks for jumping in. So we have our stack here. While stack dot top. No, hang on. It would be monotonic stack. So stack dot top target. Stack dot top is greater than target I, then we want to do something, right? While target stack.top is greater than target I, so would it want to be greater than? So if we see a greater than value, we'd what? We'd want to increase, right? feel like it's more of like a sliding window sort of thing here. It feels like it. If you solve this problem, Sylvia. Yeah, a lot of streamer. I run into codes Python. Finally, I found a stream that codes in C++. Yeah. Appreciate you joining. Yeah, I do all my stuff in C++. I started in Python, but I've been teaching myself C++ past 3 months, so thought I'd do some of these problems in C++. Well, I started doing them in C++ about like 3 months ago, so yeah. I'm happy you kind of stopped by. Appreciate you stopping by. I used to do a programming everyday series until I got a job, so I did that for like 220 days. Now I'm just kind of just streaming for fun. I don't know. You just get a lot of people watching all the time. I feel like the clickbait title like kind of pulled a lot of people in, but you know, there's not really a clickbait title anymore, so that's fine. It's more for the fun of it. So active subarray levels for each height while the top of the stack is greater than H. So we add each value, right? Say we add 1, right? We'd also have to say like and stack. Well, actually no, this is called values. And values. I think we'd have to go values dot empty. So make sure our stack is not empty, right? This needs to be values here. Values dot top. Well, 200 days. I still don't have an internship. Yeah, I'm a grad student, so I've done like 3 internships, bunch of personal projects and everything. But yeah, I'm getting ready. I'm excited to start as a full-time software engineer in January. So yeah, I got the offer about a month ago. Yeah, about a month ago actually. From now, yeah, pretty much exactly a month. So values dot top target I and values dot empty. So let's think about this, right? We have a value, right? We add this value. Oh yeah, yeah. What grade are you? Are you? I assume that you're American or something. So are you about to graduate soon? No. Target here, right? So let's go. Yes, yes, sir.
What are your holiday traditions?
Okay, let's just say this is actually no. Let's screw this. Let's just. Okay, so we add our value in the stack, right? We'll just pretend these are monotonic values. I guess it wouldn't even have to be I don't know. We add 1, right? So we would add 1 here, right? So maybe outside of here we could do like values dot add. I can't even remember what the API is, but values dot add. Say I, right? This is a monotonic stack, so we add the index, right? So this is our index value, right? We add our index value. If we see a greater value, right? So if while target top is greater than target I, so inside of our stack, if this is greater, currently a junior, I graduate next year, full semester. Nice, that's cool. Good luck to you. I just start grinding some Leetcode, doing some Leetcode, and working on some personal projects. Leetcode's fun. I've been doing it about a year now, so I'm nothing amazing, but I find it enjoyable, solving the daily problem and stuff. Target values on top is greater than target I. So if our target value's top, so if this is greater than what we're looking at here, or maybe it should be the opposite, right? Maybe it should be, well, if we see this, Maybe it should be the opposite. No, actually. Yeah. Then, but we would just like values.pop. And then we would just add the current I that we're looking at, right? Yeah, that seems like it works, right? So maybe we set our current height to be values.pop, and then we would go current height plus or equal to current height plus or equal to, it would have to be the current value that we're looking at, like current value target I, because this is greater than, we know that, minus I don't know if this is gonna work technically. Because maybe we might have all these values, right? Like we might have a bunch of these values, like we could be looking at this value here, but then I guess we're looking at every value that's greater than though, so maybe it would work. Target I minus let's make this like int val is equal to values. Well, in values.pop returns void, so it'd be like int val is equal to values.top. Then we would pop. We have to go target I minus target val. Just like return our current height. This is definitely not gonna work, but I think this would be empty. Expected expression. Maybe we don't even need to keep track of a current height, like maybe it's not necessary at all. Maybe we would just like, if the value is greater, I'm trying to think here, like maybe every single element we add, like if we have a greater one, we just add it. That would return 3. But what if we had like something like this? Right, then what would happen? Right, we would have one element, we see one less. If we see this one that's greater. No, that's not gonna work. I don't know, dude. I don't know. So yeah, if target is empty, that's what we want. Oh shit, we can't call on an empty stack. Wow. Stack values dot top. Greater than target I. I want to do values dot hop. Alright, I think that's what we want. Otherwise we add. Make sure that syntax is working there. Stack. This should be values. No. Sorry, this should be. Wait. Target. Missing some syntax here. Expected a colon. I think we have. Okay, values dot add. I think it's insert maybe. Is that what it is? Oh my gosh, dude. Push. Shit, that's what it is. Dude, I can never remember what it is. Okay, so we should be returning 0, right? So while it's empty and our target values dot top is greater than our target I, greater than current, right? So if value is not empty, so while the thing has something in it, and the value of our top value, so target values dot top of our, sorry, this should be, whoops, this should be values. No, sorry, this should be target. Wait. Yeah, this should be target because we're holding the index value. So values dot top. If that is greater than target, then we want to pop. We want to take, I'm not sure. These problems are so hard to think about, bro. Maybe like, we have our if here, right? Like if stack.empty, right? Then we want to stack, no, sorry, it's to values.push I. I used dot top. It's less than H. Less than height. Less than target. I want to see what this problem's fucking rated, dude. This is a hard problem for me to do. Everyone's saying it's so easy, but it's hard for me. Problem ratings. Let's see here. What is this one? 1526. 1526. 1872. Honestly, I'm not sure, bro. I think I should look at a solution. 1526. Code.
I'm a geology major. A real rocker. This paper is the last thing standing.
Hello and welcome back to the Cracking Fang YouTube channel. A grip on this problem. So let's think about if we have a target array of 1, 2, 3. Obviously, we know that our initial array is given to us in the same length as our target.
Yo, what's up,
except all the
Niraj,
elements
dude?
are
How you
0.
doing?
Now, what we could do is we could have some sort of naive approach where we just increment each element of our target by however many values are for each corresponding index in the actual target array, right? So for the first one, we increment it by 1. So we get 1. For the second one, we increment it twice. And then we get 3 times for the last one. In total, we get 6 total iterations. But this is the maximum number of iterations it will take and not the minimum. So we need to do better than this. And what you'll notice is that if we just do one at a time, we're actually wasting work because we can increment by 1, which means that we could actually increment everything by 1, and then we don't have to do 2 twice, we would just need to do it by 1. So if we think about this, what if instead we chose to say, okay, well, I'm gonna have everything by 1 at first. Now, instead of having to add 2 to the second index, I actually just need to increment it by 1. So we would go increment by 1, the second index, and we can actually increment the third index by 1 as well. So we now have the array 1, 2, 2, and then all we need to do is increment that last piece, and we get 1, 2, 3. And in here, we've actually only used 3 total operations, which is actually kind of the solution here. So you can see that we brought it down from 6 down to 3, which is actually the minimum. And the way that we're going to approach this problem is basically something along these lines. We want to basically just go over our array from left to right. And what we're going to do is we're going to take kind of increments in a a greedy manner. And we're basically just going to fill our target array as we go along. But what we need to do is actually be careful that we don't accidentally increment too much. So for example, when we had the subarray 1, 1, 1, we can no longer consider this element to be incremented. So we need to be careful not to accidentally add too much here. So basically, once an element is actually considered to be done, then we don't want to be incrementing any more to it because we can actually get it over what we want to do in target, and we can only increment our array. We can't then decrement parts of it. So that means that what we need to do is essentially, as we're traversing through our target array, what we want to make sure is that the previous value in our kind of array that we're forming as a part of our result, if the value of that index is actually less than or equal to the current target that we're looking for, then we don't want to be incrementing it or touching it because that means that the current number actually has already been incremented as part of kind of the greedy approach that we did before. So for example, if we were actually looking for, I don't know, let's say 2, 1, 3, obviously we'd increment everything by 1, but we would need to increment this to 2, so we'd have 2, 1, 2, and we want to basically prevent us from over incrementing this middle index when we're considering how many increments we need to do. And the way that we do this by checking the previous element. If that element is actually bigger than it, then that means that we have already done all of the increments for that element as part of kind of just taking greedily for the previous element, if that makes sense. Essentially, we don't want to over increment and overtake elements because essentially we want to take as many increment as many indexes as we can, basically as big of a subarray as we can at each step to minimize the number of steps. And essentially the way that we check that is if the current element that we're looking for to increment, if the previous value that we saw in terms of when we're building our kind of solution is actually bigger than it, then we can ignore it, because now that means that we don't want to be touching it anymore. And it's probably already in its correct space. So that is essentially the approach. Let's now go to the code editor and type it up, and hopefully this part about checking the last element will be more clear and we can actually see it in code and kind of explain how the logic works more in detail. Okay, we're in the code editor, let's type this up. Remember that we need to keep track of the previous number that we've seen and also the current result. So let's create some variables for those. So we'll say prev equals res. This difference here is because we basically assume that in the previous value from any, and we can simply return our result. Let's just make sure this was correct and we can submit it.
Oh, that's the solution.
And it looks good. Now, before we actually go, let's now look at an example here, which will kind of illustrate this topic. So we'll look at the
So for value in target, if value is greater than the previous, res posture equal to val minus previous. Previous is equal to val. That's the fucking solution, dude. There is no way that's a solution. All this fucking crap was for nothing. Like, is less than target.size I++. So if current what was it? If val is greater than previous is equal to 0. If current I is greater than previous, sorry, it would be target previous. Then current is equal to target plus or equal to current plus or equal to target I. Prev is equal to target. Prev is equal to I. That's what we want. And we just want to return cur. What they do in the video. Val minus previous. Target I minus minus let's kind of get rid of this. Curves equal to target 0. Right, there's no way that was a solution. That's crazy. Bro, I spent an hour thinking about a stack and that was a solution. How is this a hard problem, bro? Like, that's crazy. Like, it's like 5 lines of code. It took me like fucking 5 hours. Like, hey, bro. Kind of pisses me off a little bit that I couldn't get that, right? We start off 1 in front. We check if target I is greater than the previous. Then we plus or equal to target I minus target previous. Target I is greater than the previous. We add it. Let's think about it. Let's think about this, right? This is the hard one that... So we start off at... Or we start off at 3, right? We start here. Well, if target I is greater, it's not. If this is greater, then we go 5 minus 3. Then we go to 5. So this here would move to 5, right? The previous goes to 2, right? Keep going, nothing's greater than that, so we would return 5. No, but the answer is 7. Oh, but we set the previous to I every single time. That's the trick, right? So instead... Okay, so this is the previous, right? If this is greater than the previous... which it's not, then we don't add, the previous will go to 1, right? So let's kind of restart a little bit. That's the trick. So we start off here, right? We have 3. So we start off at 3. Next value is not greater than, so we skip, right? Our previous is now 1, right? It was 3. But our previous is 1. Now, we go to 5. Right, it's greater than that, so we would add 4 to that. So yeah. Which would take us to 7. And 5 is our previous, right? If 5 is greater than that, which is not, 4 is now our previous, right? It's greater than that. No, it's not. Now 2 is now our previous, right? And we'd finish and return with 7. That's a trick though, dude. I didn't think about that. Like, so 3, yeah. the reason why we do that is we go target I minus target previous is because we're putting together what's, you know, consistent here. I was thinking about like a fucking stack solution. I was thinking about like all sorts of stuff, but really the solution was just this, like, which is crazy. Like, okay. That's our problem for the day. I'm kind of tired, but I'm going to head to sleep. So, appreciate you guys watching. I'll have a longer stream tomorrow. So, peace, guys. See you later.